Humanoid robots don't start autonomous. They have to be trained, and teleoperation is usually how that training begins. When people watch robot demos, especially ones from companies like Tesla, there's a question that almost always seems to come up. Are these robots actually autonomous, or is a human controlling them from behind the scenes? That confusion usually doesn't come from teleoperation itself. It comes from not knowing when it's being used or what teleoperation actually means. So this video isn't about calling out companies or critiquing demos. It's about explaining what teleoperation is, how it works, and why it's a necessary part of how robots are trained today. By the end of this video, hopefully you'll understand what teleoperation means, how humans interact with robots during that process, and why it's a necessary step on the path to truly autonomous robots. So what is teleoperation? Teleoperation just means that a human is controlling a robot remotely. So the robot isn't acting autonomously, it's being actively controlled by somebody. But that doesn't mean a human is directly controlling every single movement or joint, or that the robot is just a puppet. A good comparison is a drone. When you fly a drone, you use a controller to tell it where to go, but you don't individually control each motor. The drone itself handles balance, stabilization, and all the other details to keep itself in the air. And teleoperation works in the same way. The human controller demonstrates what it wants the robot to do, like picking up and moving an object. The robot then follows that demonstration, but controls all the low-level details like balance on its own. So this is obviously very different from full autonomy. In a fully autonomous system, the robot is responsible for seeing and understanding its environment, deciding what to do, and then executing those actions on its own. With teleoperation, the decision-making still comes from a human, but the robot is already doing a lot of the work. So what does teleoperation actually look like in practice? Depending on the system, the human operator might use a motion capture suit, VR controllers, or hand trackers. In some setups, the human operator demonstrates a movement, and the robot closely follows the demonstration. In other cases, the control is more abstract. Instead of copying the human operator's movement, the human might just point to an object or location and give the robot a command, like pick this up or move here. From there, the robot plans the motion, avoids any obstacles, and then handles balance and grip on its own. The human is still controlling the robot, but this is a higher level form of teleoperation where the robot has slightly more freedom in how it executes its task. If this idea sounds familiar, you might have seen it in the movie Real Steel, where human operators control humanoid robots during boxing matches, with both verbal commands and direct control. That's obviously a pretty extreme version of teleoperation, but the core idea is the same. A human provides high-level control, while the robot handles the physical execution. In real robotics, it's much less theatrical, but the method is the same. The long-term goal for most robotics developers is autonomy, a robot that can basically do anything on its own. So why do engineers rely on teleoperation so much? Why not just make robots fully autonomous right from the start? The main reason is that teleoperation is one of the most common ways of training robots. When a human teleoperates a robot, they're not just controlling it for fun, they're also generating training data. Each successful demonstration shows the robot what the new task is, what doing it right looks like, and how to do it in a real environment, not just a simulation. That data can then be used to train the systems, and eventually take the human out of the loop entirely, essentially creating that autonomous robot. An important note is that teleoperation is often the fastest way to teach a robot a single new task. It only takes some demonstrations for the robot to become familiar with whatever task you need. The downside is that this approach doesn't really scale. Having a human teach a robot every single new task doesn't really work long term, because in a single factory there can be tens of thousands of different tasks that need to be done on any given day. So teleoperation isn't the end goal, it's just a stepping stone towards autonomy. So how does all of this relate to the robot demos people see online, especially from companies like Tesla? When people watch Optimus demos, the most common question seems to be, is this robot actually doing everything on its own? And right now, the answer is generally no. But that doesn't mean the demos are fake, it just means that the robots are still being trained. Teleoperation is the right tool at this stage because it lets engineers demonstrate what the robot's body and hardware are capable of, and also collect real-world training data at the same time. In other words, the demo isn't just for the audience, it's also part of the training process. In Boston Dynamics' recent demonstrations, they explicitly state that someone is controlling the robot, Atlas, by telling it where to move and what actions to perform. In other cases, like with Optimus, that human involvement isn't explicitly mentioned, which is why there's so much confusion. So when you see a humanoid robot performing complex tasks in a demo, teleoperation isn't a red flag. It's just a sign that the system is still early and still being taught. There are a few misconceptions about teleoperation that frequently come up in comment sections. The first and biggest one is that if a robot is teleoperated, it isn't autonomous. And that's not entirely true. Most real robots today are hybrid systems. They might rely on humans for high-level decisions, but they're still able to handle things like balance, locomotion, and collision avoidance on their own. So teleoperation doesn't mean zero autonomy, it just means that humans are still part of that decision-making process. Another common misconception is that teleoperation is only used because robots aren't smart enough to do things on their own. In a sense, that's true, but that's just how learning works. Robots, like humans, don't start with the knowledge of how to do everything. They have to learn things, and that learning usually comes through examples. Teleoperation is one of the fastest ways to show a robot what correct behavior looks like in the real world. So equating teleoperation with a robot being too dumb misses the point. It's not a failure, it's just part of that learning process. So what's the alternative to teleoperation? The main alternative is to let robots learn through trial and error, often inside simulations. In simulations, robots can practice tasks safely and cheaply, improving through feedback until they get it right. The robot tries different actions, figures out what works, and then improves over time. And this method is powerful because it scales much better than teleoperation. You don't need a human for every attempt, and you can have thousands of robot clones learning a task at the same time. But it has one major limitation. Simulations can't perfectly capture the real world. Small details like friction, object variation, and lighting are hard to accurately train for in a digital environment. That gap between simulation and reality is one of the biggest reasons robots still struggle once they leave controlled environments and enter the real world. But there's also a more long-term method of training that people bring up, having robots learn just from visual data, things like movies and YouTube videos. And that idea sounds good. Large language models learn from massive amounts of text, so why couldn't robots learn from enough video? The problem is that video shows what motion looks like, but not what it actually feels like. From video alone, a robot doesn't know how much force was applied or what contact actually felt like, so there's a lot of missing data. Turning visual data into something a robot can actually use is still a problem. That's why, at least for now, learning from videos alone isn't enough to replace real-world training methods like teleoperation. If you want a deeper breakdown of why this is so difficult and why robots still aren't everywhere yet, I go into more detail in a recent video. When you see a humanoid robot performing tasks in a demo today, the impressive part isn't that it's autonomous. It's how it can move, balance, and function in the real world at all. That level of dexterity and mobility is hard to achieve. Just look at how stiff and clumsy robots used to be and you'll notice the huge progress we've made. Teleoperation doesn't take away from that achievement. It's just how those capabilities are demonstrated and refined while the robot is still learning. It's important to remember that autonomy doesn't appear all at once. It's built over time as hardware improves and real-world experience is gained. Teleoperation is just part of that process. It's a stepping stone that helps robots transition from being controlled to eventually being able to do everything on their own. So when you see a robot demo and wonder whether a human was controlling that robot, don't think of it like a red flag. It's just a sign that the system is still early and still being trained.